Hi, this is Victor and welcome back to my math tutoring channel. In this video, I will be using the sigma notation to calculate the Riemann sum. And I will explain it to you while doing exercises. Let's start with the first exercise. If I have the sum of I equal 1, let's put 5 here, of 5k plus 2. As I explained in my previous video, if I have a plus or minus here, I can divide my sum into two sum. If I have multiplication or division, I cannot do that. Only if I have plus or minus here, I can divide it into two sum. So let's divide it into two sum here. So this is equal sum of 5k, I going from 1 to 5, plus sum of 2, again, I equal 1 to 5. And here 5 is a constant. It will never vary. It is the k that is, well, let's put k here to be consistent. So it is k that is that is a variable. So I can take my 5 outside my sigma, because for k equal 1, I will have 5 times 1. For k equal 2, I will have 5 times 2, 5 times 3. So what I will do, it's 5 times whatever is the answer. So this is equal 5, sum of k equal 1 to 5 of k, plus sum of k equal 1 to 5 of 2. And here, in my previous video, I gave you the sigma formula, the sigma notation formulas. And in that video, there were two formula that I can use here. The first one is if I have the sum of I equal 1 to n of whatever, 1, this is equal 1 times n. And the formula, when I equal 1 to n of I, this is equal n times n plus 1 divided by 2. And again, I told you the n that is here is the same n that is here. It is the same n that is here. So here I have from k equal 1 to 5, so my n become 5. So for this, for the first one here, let me take out the formulas. Let's put them here. Those are the formulas. I will highlight them, so it's not part of the exercise. It's only the formulas. Okay, so if I take the first one that is here, I will have 5 times, and there I had n, here I have 5, so it become 5 times 5 plus 1 divided by 2. And the second one, if I use the first formula, it becomes plus 2 times 5. So this becomes 5 plus 1, 6 times 5, this is 6 times 5, times 5 is 30, 30 divided by 2 is 15. 5 times 15 plus 10, and 5 times 15, 5 times 5, 25, 75 plus 10 is equal 85. And that's the final answer. Let's do another exercise. But this time I will keep n. I'm not gonna replace it by a number. The second one would be the sum of I equal to 6, from 6 to n of k of I square. I know there is another formula that I showed you in my previous video. Let's move this to write the formula. Let's move it here. And take out this. The formula is the sum I equal 1 to n of I square is equal n times n plus 1 times 2n plus 1 divided by 6. So here I'm going to use the formula. So it become, oh, but here I'm starting from 1 and here I'm starting from 6. So if I will be missing the first 5 items, but the first 5 items are, when I equal to 1, I will have 1 square, plus when I equal to 2, I will have 2 square, plus 3 square, plus 4 square, plus 5 square. So this is 1 plus 4 plus 9 plus 16 plus 25, and all that is equal to 55. So I can apply now this formula here, but I have to add 55 to it for the first 5 items. So it become n times n plus 1 times 2n plus 1 divided by 6. Let me delete this, now you understood it. This is equal 55. Plus 55 for the first 5 items. And you know what? Let's make it a bit more interesting. I will put to n minus 1 here. So let's change it. So as I told you, the n that is here is the n that is here. So I will start by n minus 1. I replace every n by n minus 1 times n minus 1 plus 1 times 2. Let me take out the 55 from here. 2, and I'm gonna replace n by n minus 1 plus 1 divided by 6, and I add the 55 to it because of the first 5 terms. So here it will be equal to n minus 1, and this minus 1 plus 1 is 0 times n, and here is 2n minus 2 plus 1 divided by 6 plus 55. So I will rearrange it. It's equal n times n minus 1 times 2n minus 2 plus 1 is minus 1 divided by 6 plus 55. And if I want to have it more neat than that, I can multiply by 6 and divide by 6 to have a common denominator. It will become n minus 1, 2n minus 1 plus 330 divided by 6. Because 55 times 6 is 330. Let's do another exercise and we end up this video with it. The other exercise, the sum of, let's call it k this time, k equal 1 to n minus 1 for k divided by n squared. And here my variable is k, it's not n, so I can take out my n outside my sum, and my final answer I will multiply it by 1 over n squared. And I will take 1 over n squared outside my sum. It become k equal 1 to n minus 1 of k to the power of 3. And in my previous video I gave you the formula, and I told you you don't have to prove it, you only have to use it. So the formula said the sum of I equal 1 to n here of I3, it is equal to n squared times n plus 1 squared divided by 4. And that's a formula, so I will highlight it. And here I will use this formula here for this. So it becomes 1 over n squared, and instead of n, I have n minus 1. So it become n minus 1 square, and here I will replace this n by n minus 1, n minus 1 plus 1 divided by 4. So if I like, this will become n. This is equal 1 over n square times n minus 1 square, and this is minus 1 plus 1, it's 0, times n divided by 4. And I can simplify here by n and by the square that is here, so the final answer 1 divided by n multiplied by n minus 1 square divided by 4. And that's my final answer. So if you like my videos, please subscribe to my channel, and I would appreciate if you put a like for my video. This way it will help me do more videos for you, and it will help you pass your course. Thank you.